There's also a second type of net external force problem, and it's called a non-perpendicular. And here as well, you have a free body diagram, except instead of just having one vector going across saying the amount of newtons you have a vector and telling you how many degrees it is away. In this case, it's 70 newtons going north of east at 45 degrees. So then to find the two vectors right here, we are going to have to resolve the force vectors into components using sine and cosine functions, which you can see right here. F of x equals 70 cosine 45, which is simply the 70 newtons from right here, and then the 45 degrees, and that equals 49.5. And you do the same thing for the y, except you use sine. You take 70 sine 45, and as well you get 49.5. And to make it easier on yourself, I would say draw another free body diagram. Right here you have your 15 newtons, the 100 newtons going north, the 98 newtons going south, and now instead of having this little angles and vector going right there, you have two vectors showing you the east and then another vector going north. All this means is that when you're solving for the sum of forces in the x and y directions, is that you take this number for the right and this number for the left, which is what you would usually do. But for the f of y right here, what you do is you add these two together, which you can see right here, and then you minus it by the south vector, and you end up getting 51.5. You then draw a resultant triangle, and since everything's positive, it's merely going 34.5 newtons east and 51.5 going north. And then you draw the final vector to show where you have to solve NEF and the angle you want to solve for. You then use the Pythagorean theorem to solve for the NEF, and then you square them, and you take the square root to get the NEF alone. And in this case, the net external force equals 61.99 newtons once rounded. And then to solve for the angle, you take the inverse of tangent over 51.5 over 34.5, and you get the angle to be 56.18. And then you find to be that the net external force is 61.99 newtons at 56.18 degrees north of east. Alright, so there's simple ways to solve perpendicular net external force problems, and the first thing you want to do is make sure that you have a free body diagram like here. This one simply shows 1 kilogram and then 5 newtons acting upon it, 25 newtons, 9.8 going down, and then 10 going to the left. And then the next thing you want to do is sum up all the forces in the x and y direction, which basically means that you minus the right from the left and then up minus the down, and you would get 5 minus 9.8 newtons, which is negative 4.8, and then 25 minus 10, which is 15 newtons. Once you get your differences, what you want to do is draw a resultant triangle, which is right here. And since it's negative 4.8 newtons, what we do is we draw the vector going down. And since the 15 is positive, we simply just do it across going in a positive direction, which in this case would be going right. And to create your triangle, of course, you would simply draw a vector going from tip to tail on two vectors, which you can then label the net external force using NEF, and then draw in the angle you would like to solve. And then to solve the NEF, what you would want to do is use the Pythagorean theorem, which in this case, we will plug in 4.8 and then 15. Then we would, of course, square them, get our two values right here, and take the square root, because we don't want to get the net external force squared. We want to get simply the net external force, which comes out to be 15.75 once it's rounded. And then we would use the tangent function to solve for your theta right there. And then to solve that, of course, you'd have to take the inverse of tangent to solve for your angle, which you can use any old calculator. I used this one. And the angle turns out to be 17.74 degrees, which then leaves the net external force to be 15.75 newtons at 17.74 degrees south of east. And that just shows you that perpendicular problems can be solved fastly and easy, and there's really nothing too much to do to it. I mean, it's very simple.